A hearty welcome to today's session of the Digital WE Days with a very interesting topic today, cybersecurity, a practical approach to secure connected devices. And for that, we have two interesting speakers here as well. The one is Madanahalli and Pascal Baranger will be joining. But before, a few hints. You will be muted during the presentation, but on the right-hand side or on your browser, you can always ask your questions in the chats, and we will try and answer them at the end. That is one issue. We'll spend about half an hour for the presentation, and thereafter we'll give you about 15 minutes for questions and hopefully answers. So without further ado, let's tackle this interesting topic of cybersecurity. And we have here Pascal Baranger. With that, I'm going to hand over to you, Pascal. Introduce yourself. Carry on.
Great. Thank you, Manfred. Also, warm welcome from my side. My name is Pascal. I'm part from the IBM team, and we will present you today's topic, how to secure IoT solutions. And I have our special guest here, Adi, with us. Maybe Adi, well, I say Adi, but introduce yourself to the participants, and I hope it's okay for me. Yes, I say Adi.
Sure. Yeah. Thanks, Pascal. Adi Madanahalli is my name, Adithya Madanahalli. I'm from the R&D team and very happy to be here today. Thanks for the introduction, Manfred and Pascal. Very curious to start presenting.
Great. Perfect. I would say let's directly dive into the topic and let's share your screen and we will have a look to the agenda, what we will talk about today. So we will start about the topic, what is IoT? Then we will see to the components of an IoT system. We will speak about cybersecurity in IoT. Then we will speak about the regulatory landscape and best practice of an IoT, scalable and secure cloud connectivity solution, radio proprietary tools, and this was all for today. But first of all, Adi, maybe you can explain us in some very simple words, what is IoT?
Sure. Just to set the context for today, I'm going to talk about embedded applications wherein you have the process of acquiring data, transmitting the data that you acquired through the sensors over a wireless connectivity link. You can also use the wired connectivity line, but let's make things interesting. Use wireless connectivity and then send the data to a data platform where it is saved, processed, and used to analyzed to generate some kind of value addition, which makes the whole application that we talk about smart. That is the intention of using IoT. So what are these value additions that we talk about, right? So you give the possibility of optimizing processes. It may be industry or any other application. You can perform predictive maintenance. And of course, in the end, the whole idea to do all these advanced stuff is to make sure that you create a safe environment for people to work in and to make the whole process secure. Of course, there is a possibility to improve quality of the deliverable results and to make sure that because of the whole digitalization process that is happening, you are able to generate new business models.
Yeah. Okay.
Cool. That's the whole importance of what an IoT application means.
Yeah. Okay. Sure. You said smart, and I think probably at the end everything is capable to connect to the internet. But let's have a closer look on exactly what could be a real IoT application. So when we think about IoT and smart, for sure there's the industry, the smart industry, which comes to my mind. Smart farming is becoming a bigger and bigger topic.
Yes.
Because as we all know, the population here on the world is growing, so we need to produce better and smart at the end, smart cities. To connect everything in the city together. And for sure, I'm pretty sure that everyone knows from home. I know it, you know it, everyone out there also know it. Smart home devices are getting more and more popular.
I mean, to summarize, you can see the pattern here, right? So you take an application, you provide, let's say, IP-based connectivity. So you transmit the data over the internet into a data platform. you're creating an IoT application, basically creating a smart application.
Yeah.
Right?
Yeah, cool. And Adi, the first topic we had here was industry and smart industry. Everyone is talking about industry 4.0. So maybe you can tell us how to integrate the IoT solutions into the new industry 4.0.
Sure. The industry 4.0 is kind of a concept that marks the fourth industrial revolution. It involves multiple technologies, as you can see in this slide here. One of them is the Internet of Things. So the industrial Internet of Things, or Internet of Things, is one of the enabling technologies that creates us the fourth industrial revolution.
Okay, perfect.
Moving on, I think it's time to dig a little bit deeper into what are the components or the constituents of an IoT system.
Yeah.
So typically, you can see here that a typical IoT system consists of starting from sensors or actuators in the ground, which have the function of reading a physical value, let's say temperature, pressure, humidity, and so on.
Yeah. Yes.
Digitizing it and making sure that it is in a digital presentable format. So this is where the whole interaction between the physical world and the digital world starts.
Yes.
Right?
Yes.
From there on, the data is transmitted over the gateway.
Mm-hmm.
Gateway is typically an instrument which acts as a translator between the low-level embedded devices and the high-level cloud. Yeah. So this is the in-between layer, and finally the data lands up in the cloud. In this case, a data platform is in the cloud, mm-hmm. which is typically the application use cases. And from there on, you can use the data present in the cloud to perform advanced analysis and so on, and finally present the results in the form of a dashboard or any other way using your mobile devices or a desktop or something like this. So this is how the whole IoT system is built from the ground up. Let's say in this case, where we talk about in the field, you have the embedded domain, where we are talking about a microcontroller based system, which is where the focus is on small size, low processing power, but it has to be really power efficient, and where you don't have much much resources to deal with.
Yep.
On the other hand, when you're talking about the cloud domain, there you have a lot of things, a lot of high processing power available, but there are other problems like scalability and flexibility and so on becomes more factors that you need to optimize, right? But imagine this whole big complicated system, so that you're dealing from a physical device in the field to some virtual devices in the cloud. So it can get really complex when you take the whole system into perspective.
Sure.
And we have to make sure that the whole system is, in the end, secure, scalable, reliable, and so on.
Yeah. Great. Perfect. So just to give a little recap, at the end, we have some sensors which are connected to the wireless connectivity. The sensor data are getting further to the gateway, from the gateway into a data platform. And then at the end, the user can see it on his own interface, what the sensor is telling us. Correct. And for sure, all these segments need to be secured.
Correct.
Okay. Perfect. Correct. Great. So now we have prepared a little survey for you. We hope that it will work. We have prepared a question or two questions at the end, the total. What is the most important aspect to consider when developing IoT solutions? And the second question is, what is your key concern regarding IoT implementations? And therefore, we would kindly ask you to give us your response, and we will have a closer look together. We'll just give you some 15 to 30 seconds, and then we will have a closer look to it. As far as I can see, that it's already working.
Yes,
I see some answers. Looks good for me. Perfect.
Really like this way of interacting and getting your opinion, right? So it's something really cool.
It's cool, and at the end, it's totally new for us.
Yes.
So we can interact with you directly on a different way.
Yeah, feel free to also choose and answer more questions, and we put in your questions in the chat window as well, so that we can answer it during the Q&A session.
So we have 34 answers in total. Let's wait. Let's say 10 to 15 seconds more, and then we will have a look to your answers. So perfect 37 answers, I would say. That's 41. Let's start with the results.
Yes,
so
sure.
They're good. So I can see on the first question again, what is the most important aspect to consider when developing IoT solutions? Your answers were are communication, reliability, and security. These are the most important things. And for the second question, what is the key concerning regarding IoT implementation? The most important thing is security, and maybe then we can also closer look to your results that you bring us with us.
Yeah, this is a survey that was done offline, I think, a couple of years ago.
Yeah.
And it is really pleasing to see that if you take the second question, the percentages almost match. So the on the top of the list is security, which is again the case here with 45% and so on. And you have the connectivity, interoperability, and ecosystem. So this is what we wanted to tell with this kind of survey. It is kind of very clear that IoT security plays a very important role.
Yeah,
right.
Sure.
So security.
Sure.
But why do we think about security? So this is where you see that the system becomes very vulnerable when you don't take care of security. And you can ask what happens. I mean, there is a chance that there are financial losses behind it. There are, of course, heavy penalties that we will come to this when you are not compliant to IoT security very soon in the next 5 minutes. I think there is a reputational damage, and there are others other than tangible costs. There are other costs, hidden costs that the company has to pay when some kind of breach happens. During this.
There have some nice example in my mind. Probably you heard of it. There was a casino in Las Vegas which was hacked in 2018 by the temperature sensor which was inside a fish tank or an aquarium.
Yes.
And then the hackers could get access to the whole casino system.
Correct.
Crazy. It's crazy.
So this is an incident. I mean, it's the most interesting part is that the thermometer or the temperature sensor, it costs, let's say, a couple of dollars or a couple of euros.
Yeah.
But the implication in the end was millions of dollars that were stolen from the casino itself.
Crazy.
So even a small device, you can say, oh, it doesn't cost much. Why should I take care of security? But that's not the case. You have to make sure even the weakest link in your chain is secure so that you can secure higher value assets.
Yeah.
Right. So that is the whole significance of cybersecurity.
Yeah. Okay. Yeah. And Adi, did some governments or any other people learned about this hacking issue, and did we implement something after 2018?
Yeah, sure.
Yeah.
I mean, there are not just this incident, there are multiple incidences that you hear in the news. There are lights being hacked and the whole building automation being hacked and so on. So the governments worldwide are taking this into cognizance and playing a very important role by bringing out a lot of new legislations. So this shows a regulatory landscape worldwide.
Mm-hmm.
And like all the other standards, you see a division. There is light blue and dark blue, which in this case indicates a lot of the things that are a lot of countries that are following US-based standards, and there are other countries in light blue that is marked here following standards based on what EU is working with. So there are these two things that is going on worldwide, but as you can see, there are a lot of nations worldwide coming up with new regulations, taking IoT security very, very seriously.
Yeah. And I'm pretty sure that in future, the topic will getting more and more serious and more important for every one of us.
Correct. Yeah. But for today's presentation, let's focus on the EU part of it.
Yes.
Because this is the more relevant one for us, and also it's more recent, so which means that looking at the timeline, which we will come to very soon, there is already some movement happening in the EU space. So I'm pretty sure we are all aware of the Radio Equipment Directive. This is an official regulation from the European Union, which is applicable to every device that transmits or receives wirelessly data. So which includes different articles. The 3.1 deals with health and safety.
Yeah.
You have the EMC, electromagnetic compatibility with 3.1b. Then you have the 3.2, which deals with radio spectrum, wherein you have transmit power, receive sensitivity, and so on, right?
Yeah.
But since end of 2021, with beginning January 2022, the European Union have come up with a new delegated regulation on cybersecurity, which activates 3 new articles, 3.3D, E, and F, very specifically to be compliant with cybersecurity standards.
Okay.
Which means that every device that has a radio part in it, which transmits, receives data, now needs to also be compliant with the new cybersecurity standards.
I see. Maybe we can have a closer look to the red market new regulation that. Perfect. There they are.
Sure. The Article 3.3D deals with network protection, which is intended to make sure that there is no misuse of the network and there is no impact on the services, so that there is no degradation of service, to make sure that the network is fairly used. The second one is related to data privacy, wherein there are safeguards available to make sure that the personal data or any data that can be linked to a person is protected over the internet, right? The third one deals with basically fraud protection, wherein any device that deals with money or any resource that has monetary value, such as virtual currencies and so on, are protected. So these are the 3 new articles that have been activated since the beginning of January 2022.
Okay, cool. Sounds interesting for me. And now, we have learned about these new regulations, but when does they come to effect, or is there any timeline which you can show us?
Sure. Like I said, since it has been approved by the European Union as accepted as a new legislation on the 1st of January 2022, the transition period has been activated from February 2022.
Yeah.
Usually, when these kinds of legislations happens, there needs to be a harmonized norm that needs to be created so that the users or the manufacturers of devices can be compliant. They can check their devices against these standards. So there is a standardization, harmonization process that is happening currently. But currently, there is a deadline of 1st of August 2025, after which all devices have to be compliant with these standards in order to be operated within the European Union.
Okay, I see.
But since there is no harmonized standard available yet, we feel this is the landscape of standards keeps changing day after day. So this is the best guess from our side that there is going to be the deadline is going to be postponed.
Okay. Well, let's see next year.
Sure.
What will happen?
Correct. So this is the current situation. Since I was talking about the harmonized standards, so I just wanted to give you an update on what is this harmonized standards that has been worked on. So this is the EN 18031 -1, -2, and -3 for each of the articles. The European Commission has given an order to Sensenelec to prepare to draw up these standards. Sensenelec has come up with the first draft. But as of January 2024, this draft was rejected because of the lack of practicality, which means that these standards and draft needs to be in such a way that you can actually write test cases out of it, and you are physically able to test these devices and make sure that the devices are compliant to these regulations, which means the current standard that the draft that we have, the current version, was declined and rejected, which means we have to wait for the next version.
Okay, let's see.
Which is why, again, there is a really high level of uncertainty with the deadline that we spoke about earlier.
Yeah. Okay. Good. Since there's no harmonized standard for the moment, how can device operator can be compliant?
Yeah, that's a good question.
Yeah.
So the Radio Equipment Directive specifies that there are 2 ways. So if there is a harmonized standard fully applied, available, right, then you can do a self-declaration like you do always for the Radio Equipment Directive.
Yes.
And if it is not available, then you have to go through a notified body, which is usually a certification house, the test house, and get each and every device notified to be compliant with the Radio Equipment Directive. Now the question is, if the standard is in still draft version, right? So how do the notified bodies do this? So the Radio Equipment Directive has given guidelines to use the EN 303645 norm for the consumer products and IEC 62443 for the industrial products to use as a baseline to certify devices to be compliant with the Radio Equipment Directive.
Great, perfect. Sounds good. Adi, probably you can show us the content of the standards that you have just mentioned to us.
Yeah. I mean, I have summarized this, the requirements of all these standards in a very simple way. I mean, irrespective of what standard we are talking about, so it kind of specifies very basic principles, right? In terms of software, do not use default passwords, ensure that the personal data, irrespective of what it is, it can be as small as one single email address, right? Is secure. You have to make sure that every input that goes into every interface is validated.
Mm-hmm. Okay.
On the hardware end, it is really important to make sure that the storage of sensitive parameters is secure. Make sure that every communication link is secure and authenticated. And as much as possible, minimize the exposed surface attacks. What does this mean? This typically means that you make sure that you close all the ports that you don't use, right? Don't allow the attackers to have multiple options. Make sure that only the things that you use are exposed. Finally, to make sure that your software integrity is maintained, because most of the time the software is closely combined with the hardware, which means on a flash memory, to make sure that there is some kind of integrity check done before a software is being used. So this is on the technical part, but on the policies, this is also very important that every company needs to come up with an implementation of a reporting system. So what does this mean? If some person finds a vulnerability in any product, there should be a system in place to make sure that they can report this. So this already exists in a lot of high-end devices. For example, if somebody detects a bug in iPhone, iOS, it's worth millions actually if you report it to Apple, right? Yeah. So this is already happening. Then you should also have defined policies to keep software updated.
Yeah.
So this is like really mandatory. Windows rolls out a lot of software updates. Yeah. So next time when you get something from your IT department, make sure you update the software. Right?
Sure, always.
Examine telemetry data. Make sure that there are steps taken to install and maintain devices, and also to make sure that any person-related data, personal data, is stored securely, and there is also a possibility to explain to the user what is done with the personal data. So this is where there is a linkage between the cybersecurity part and the GDPR. So these are the policy part of the common cybersecurity specifications.
Great, perfect. Thank you, Adi. So now we had a closer look into software, into hardware policies, and the question which comes to my mind is how to implement all these three topics into an end device, an IoT end device.
Sure. Yeah. I mean, at this stage, since we do not have a finalized, harmonized norm, what we can all do is to make sure that we consider security into the design of every product that we do.
Yeah,
right?
Sure.
So take care of small things like you have a secure boot implemented. This is very simple to explain this. So whenever you have an application booting up, make sure that you check the integrity of this application using a secure bootloader. There are multiple implementations available. I'm also requesting my colleague Bodo to share a couple of links here wherein there are a lot of best practices available. For example, one from the IoT Security Foundation. They come up with nice white papers and so on to show these best practices, right? Further, you can take measures to make sure that all the sensitive data, either it is personal data or it is some kind of private data using like a password, like a private key and so on, are stored in a secure file system.
Yeah.
Right?
Sure.
Then always use a secure connection, which means make sure that every connection is authenticated and end-to-end encrypted.
Yeah.
There are multiple ways of doing it at different levels. Using TLS is one of the common ways. Of course, you will need an infrastructure with certificates and private key and so on, and you have to handle all these things securely. But there are ways to do this, right?
Okay.
Make sure that you have a secure root of trust. It is very important. Every device must be individually and uniquely recognizable, right?
Sure.
To make sure that you can perform authentication and finally trust the device in the end.
Yeah.
Right.
Yeah. Correct.
Finally, we come to the topic of firmware updates again.
Yeah.
Updating the software, updating the firmware. It is really essential to make sure that every component in your system is updated.
Yeah.
So these are I have summarized this very simply in a single slide. Of course, there are more things that needs to be considered when you are doing a secure design. The most important giveaway from our side today would be make sure that security is made mandated by design and not as an afterthought. Right. So I have shared a couple of links here with you guys to get deeper into the topic. And it is really mandatory for to take a systematic approach into cybersecurity within every device, irrespective of how big or how small it is, and to make sure that you consider these basic design principles in your end device.
Yeah. So at the end, make sure not to forget something. If not, the same thing can happen as a casino in Las Vegas. You forget about the temperature sensor in the fish tank, and then you get hacked. So great. Thank you for this overview, Adi. And probably you can tell us, or probably the one of the most interesting questions from the participants out there: how can Wird Electronic support our customers, our participants with IoT security?
Sure. I mean, we make sure that we also practice this, that we take care of, we do a security analysis internally to make sure that our radio modules are secure by design. So we provide a good platform, a secure basis for end products. So in this case, let's consider the Calypso Wi-Fi module. It has a unique ID. It implements secure boot. It has possibility to update the firmware over the air.
Yeah.
It supports all the latest Wi-Fi standard security features like WPA3, TLS 1 or 2, and so on.
Perfect.
This is similar with our Bluetooth module, where we support the state-of-the-art Bluetooth standard-based security properties. For example, the LESC protocol. It also implements a secure boot. There is a non-tamperable unique ID, which means security by design, right? I would like to also point out another example where the module itself, we use proprietary radio module, and it is hard to provide all the security features right out of the box just for the module itself. But this can be also useful for end devices, like a typical retrofitting concept. So here you can see that we have integrated a secure element, which can be used to make the whole system secure. So you can see a platform, a radio communication platform with a cryptographic coprocessor. Make sure that you have the required root of trust and the possibility to encrypt, decrypt messages in the end to make sure that your wireless link is again secure.
Good, perfect.
Moving on to a little bit more on the IP-based side, Wi-Fi cellular connectivity. There you're dealing with TLS, MQTT secure connectivity. So here we are talking about connectivity to cloud, and the of late, no cloud service provider allows you to connect insecurely. So you have to have the necessary public key infrastructure implemented on your end device, which means certificates, private key, and so on, already stored on the device. So we offer a very unique solution with our partners. QuarkLink is a solution from our partners called CryptoQuantique, wherein we make sure that we take all the complexity away from the end device manufacturer to make sure that your device is secure out of the box.
Yeah, sure. And as you can see, we from Wird Electronic, we take security very, very seriously, and it's very important for us that the modules are secured, that the connection is secured, and perfect. So the thing is, if for sure, now you want to play around with our modules. You want to test them. We have some feather wings, which you can also find on the homepage, where you can easily plug and play around with these feather wings, send data from A to B very easily. I can say that in less than 30 minutes, you can also start sending data from A to B. These are stackable boards which are available. We can highly recommend them if you want to play around just to order one of these. If not, you can always send us an email, and we will send them out to you.
Sure.
Perfect.
To round up the whole discussion on Internet of Things, right? So we want, we just don't want to explain this theoretically. We want you to take things into hand, start working with it. So the good starting point would be to use our IoT design kit. This provides plug and play connectivity with Microsoft Azure and multiple other platforms. If you are interested, just take a look. This is also a very good tool to check, to get yourself acquainted with the whole certificate and secure connection concept. Here we provide PC tools and also step-by-step description on how to connect your device securely to cloud, basically in this case, Microsoft Azure Cloud. But here you already can get a glimpse of what and how the link between the sensor and the cloud is authenticated and encrypted. So this is a very good starting point. Just on security.
Adi, can you tell me how long it roughly takes to implement it and to get the first data?
It should be less than an hour, even faster.
Even faster.
So you have here a quick start video, a demo, and also I'm pretty sure a Money Talks unboxing video. Really cool. So just take this with you and start testing this, and you can build up your own prototype. These are not just one-time use boards. You can extend these boards again. We provide the hardware and software as open source, which means you can create your own hardware, also change software, integrate different sensors, actuators, switches, relays, so on. And to make sure that you can also play around with the cloud, right? So you have the Microsoft Azure IoT Central platform here, which is also kind of tailor-made for prototyping, which means you can learn a lot of new cloud concepts using these things. If you're new to cloud, you don't have to worry about this. There is no complex coding involved. It's drag and drop. You can create your own dashboards. You can go more advanced, create notifications, send emails, and so on. It's really a good place to start.
Great. So at the end, you can do a lot. And I think that we gave the participants a nice idea of how to see IoT security, what is important, what to think about. And now we come to the most important part also. We are here to answer your questions. As far as I can see, there's already some questions coming from the chat. Probably we can have a look to the first question.
Yes. Well, from my side, thank you very much for the two gentlemen here, Adi and Pascal, for a very, very interesting topic. We don't have many questions yet, but I have one or two more here. Let's just have a look at the first one. Somebody said, I have a BLE module in my design. Do I need to be compatible with the RED cybersecurity norms?
Sure. I mean, it's a very good question. The norm, currently the draft norm says you have to be compliant with this particular, the cybersecurity part of the radio equipment directive, as long as you create a direct or an indirect connection to the internet, which means in this case, it's a Bluetooth device. Unless you use the IP stack on top of Bluetooth, you don't connect directly to the internet. But let's say you connect to your mobile phone, which in turn connects to the internet. Then yes, you have to make sure that you are also taking care of the 3 new cybersecurity norms. Sure.
Okay.
Yes. Okay. Thank you very much, Adi. Let's just have a look at the last question here. Can we download the documentation? Yes. Our technical guys in the background are taking care of that. You can certainly download that. By all means, make use of the opportunity. I have one more question here. What do you mean by harmonized norm in terms of cybersecurity? Could you maybe elaborate a little bit on that?
Yeah, sure. I mean, a harmonized norm is a standard that is created by one of the standardization bodies recognized by the European Union. It is either ETSI, the European Standardization Institute, or CEN or CENELEC. So these are the three officially recognized bodies in the EU. And these standardization bodies create standards so that the end device manufacturers can, check their devices in accordance to these standards, and ensure that they are compliant to the legislations that are created by the European Union. To the question, when are the norms harmonized? So they are harmonized once they go into the official journal of the European Union, right? That is when you can say officially the norm is harmonized, and after which you can use these norms to create a self-declaration. So much about harmonized norms.
Okay, great, perfect. Manfred, are there any more questions coming from the chat?
Yes, one more here. My device uses Wi-Fi to host a web server for device diagnosis. Do I have to comply cybersecurity norms as I do not have an internet connection?
Wi-Fi is an internet connectable device, right? And I mean, it comes in the end, but it is not that it's kind of, it's about the definition of what you do. So what you define your device as standard operating mode, and what is the configuration mode. I mean, of course, if you get into these norms, you take, for example, the EN 303645. This is a very good starting point, right? It's for consumer IoT devices, but doesn't matter. You can go through individual articles within these norms. Then you'll get a really good idea of what you have to expect. So in this case, you will still need to comply to the norm, but that doesn't mean you have to do some extra additional action or so. Basically, in this case, to be safe, make sure your HTTP connection is secure, which is possible, quite simple to do, encrypted and authenticated. Even though it doesn't go through the internet, you're still secure, right? And you're still compliant to the norm. That's what I mean.
If you want to place it on the market, then you require this. I see there's one more. How can the root of trust be implemented within an offline device that is using radio, such as Wi-Fi or BLE locally?
So root of trust typically comes with the unique identity. So this unique identity is usually within the device itself in hardware terms, and make sure that it is not temperable. So usually all the modern day microcontroller comes with such a unique ID, and this can act as the root of trust. Further, you have the latest generation of ARM Cortex processors, which come up with a secure security focus. Basically, they have a secure implementation environment. Root of trust is one of the things that is included out of the box. And if you're considering older devices, older microcontrollers, which do not have a root of trust themselves, like I showed in my presentation, there is always a possibility that you integrate a secure element, which is available off the shelf, not very expensive, may add a couple of more cents to your end design, but in the end you'll have secure. It will give you a secure root of trust, as well as giving you the possibility to perform end-to-end encryption, offloading all the cryptographic operations from your main microcontroller. So there are multiple ways of creating a secure root of trust.
Okay, lovely. Yes. Maybe one question more from my side. The feather wings, which you mentioned and you showed earlier on, with the Calypso, the Wi-Fi, BLE, and also the cell. Have you kept in mind the cybersecurity? Has it been designed into these modules?
Sure. I mean, we have, for example, for all our IP-based connectivity modules, cellular, Wi-Fi, the new LoRaWAN module as well. So we make sure that all the cybersecurity standards are implemented as we have, as expected from the standards. So we use the TLS stack to make sure that the IP connectivity is authenticated and secure. And in terms of Wi-Fi, we have WPA3 and so on. So this is, and we provide also on the Featherwing platform ways and means through our software development kit to test these concepts as well. So this is, we have implemented this.
Oh, lovely, great. Thank you very much, Adi. There's one more question coming in here. What does the term ECO mean for an IoT device? Is it simply a battery life in the field?
Not sure what ECO was meant. So maybe a little bit more explanation is necessary to answer this question, I guess.
ECO possibly could refer to
economic device, something.
Yeah, I mean,
because also it's battery powered.
I mean, a lot of just to give you a generic information that there are a lot of devices, small sensor nodes which are battery driven. So it is really essential to make sure that the power optimization takes place on these end devices. But the question is there a compromise between security and making sure that you use the minimum current possible and still be secure? Of course, there is always a compromise, right? You do some kind of cryptographic operations, which would take additional CPU cycles, which means additional battery consumption.
Yes.
But that is exactly what I mean by performing security by design, performing an analysis, making sure that you do all these things in advance when you do the design, and make sure that your compromise doesn't compromise the end device. If I can summarize it that way.
Great, perfect. Thank you.
Okay,
it's very nice.
I see no more questions. Any more comments from your side?
Well, at the end, I would like to say thank you to the participants. We hope you liked the session. Thanks to Adi for this lovely presentation. Cybersecurity and IoT solutions are hopefully a bit more clear now. If there are any further questions, don't hesitate to send us just an email, wcs@we-online.com. We are here to support you. Thanks. I would hand over again to Manfred. We say thank you. Goodbye. Have a nice afternoon.
Yes, and from my side as well, to all the participants, it was good to have you in this session, this webinar this afternoon. Thank you very much to Pascal and to Adi, and also to Bodo on my right-hand side doing the technical work in the background. From my side also, thank you very much, and I hope you had an interesting session concerning cybersecurity. Till next time, keep well and farewell. Bye-bye.